Hopefully you all had a good evening last night, and a good day today. But today we're going to be talking about the next part of this networking section of Careers in Code. So, quick review. Yesterday we talked about networking. We talked about how computers communicate between each other. Talked about TCP and TCP sockets and a bunch of important networking concepts like DNS, like ports. And we then moved from there into actually sending messages between terminals, sort of like to yourself, but again, like over the internet, and then kind of ended yesterday with sending messages to this server I wrote that in a certain protocol that's sort of like a language that the server understands. That example at the end of the day yesterday, that's kind of where we're going to pick up today. Only today we're going to be, instead of using a toy protocol that I sort of built as just like a example to help you all understand the idea, we're actually going to be talking about a real protocol today. So like something that actually exists and is actually used in the world. So that should be fun. And I'm going to share my screen. We can get into that. Okay. Can you all see my screen? Okay, head shaking. I think that's good. Yeah, I think I'm trying to do it right. Okay. So today we're talking about section 2. What is HTTP? So HTTP is another protocol, the Hypertext Transfer Protocol. It's a protocol, just like our little protocol yesterday, our example protocol yesterday. It's built on top of TCP. So Transmission Control Protocol, that thing that sort of is like how computers communicate on the internet. HTTP is the protocol that web browsers speak. So when you go to a website, your web browser sort of like speaks HTTP and gets back the data that's actually shown to you on that website. We're going to talk a little bit about how that works. But also, it's important to know that, remember yesterday we talked about ports and how many protocols sort of are by convention tend to operate on a port. Well, HTTP by convention operates on port 80. So what that means is in general, if we're talking about HTTP, we're talking about HTTP communication, and you don't see a port listed with things going forward, you can just assume it's 80. Okay. So HTTP is a protocol. It involves two different systems communicating. And I used these words yesterday. I didn't really define them yesterday, but we're going to actually define them officially now. Client and server. So a client is like your computer, your laptop, a web browser running on your laptop. It is sort of like the requester, the one asking the question. The server is the other side of the equation. That's a piece of software that's running on a computer, often not your local laptop. Usually some computer, often a data center somewhere, something you can't actually like put your hands on physically, but like it's out there, it's running software. Importantly though, it's connected to the internet, it's got a network connection. And that server software can receive incoming network requests and sort of handle them. It can serve the request. This client-server sort of model is something that's very common in protocols. You're not going to see it in every protocol, but I would say like a large majority of them kind of follow this pattern. Just like I also mentioned, I mentioned this yesterday, but whenever you have a client and a server, the server has to be running before the client can send a request to it or ask a question to the server. The analogy I made yesterday was like, imagine if you want to send mail to a house that doesn't exist yet. Like, that's not going to work. So the server has to be running. The client makes a request to the already running server. But on that note, let's sort of walk through kind of the steps here of how this protocol tends to work. So notice in the upper right here, I have client and server, the little C and S computers. So the first thing that happens with HTTP is you have your client and server, and the client will connect to the server over the internet. The client will then send the server a bunch of information. This part of the whole protocol, this like the interaction, this is called the request. Sort of like the name we use in HTTP parlance to refer to this part of the interaction. Then once that request happens, the server, let me post the presentation in the chat. I think someone had asked me for that. Once that request is sent to the server then receives it, parses it, unpacks it, and looks at it and does some thinking. It's like, okay, here's my input. What do I need to do with this input? It could do a lot of different things with that input. Some common things you often will do are like store information into a database or do some math, like take parts of your input and do some math on them. Or maybe even like the server now will make a request to another server. So like you have sort of a second request where the server in the first request is really like the client for the second request. There's a lot of sort of things you can do, but fundamentally, like it's the ball's in the server's court at this point. It's sort of got to like figure out what it wants to do next. Once it has the result of whatever request you've asked, then it will send that result back to the client. This part of the interaction is called the response. So request and response, and it always goes request response. Then you're done. So that's very high level how HTTP works. But I haven't actually gone into like any real details yet. I think the best way to do this is I want to do a little demo for you all that'll be show you actually like a peek behind the curtain of what's actually going on with HTTP. And then we're going to take some of what we see and we're going to break it down a bit, talk about what all the bits mean. So if you all remember yesterday, we did that demo with netcat where we started a server running locally with netcat-l. Then we used netcat to connect to that server, and we were able to send messages back and forth from one to the other. Hopefully you all remember that. It's just yesterday. What I'm going to do is that same thing, but there's going to be one key difference. And that one key difference is instead of using netcat as my client, I'm going to use a web browser as my client. So I'm going to run netcat locally, listening in listen mode, and I'm going to listen on port 80. Also, to be clear, you folks don't have to follow along with this if you don't want to. I mean, if you want to, you can, but I'm going to kind of run this through this a bit fast. So I'm going to run netcat locally on port 80. And then in my web browser, I'm going to open up a new tab and go to this URL here, localhost:80. And what this will tell the web browser to do is to make a request to localhost on port 80. And when it does that, we'll be able to see what was included in that request in netcat. See how I'm swapping out the netcat client for a browser, but otherwise it's the exact same sort of thing we did yesterday. Does that make sense? Can I get some thumbs up? Okay, great. Okay, so to do this, I'm going to start by doing sudo nc-l80. You might be wondering why I'm putting sudo in front of the nc-l we had yesterday. You have to give netcat some special permissions if you want to listen on ports under 1024. It's sort of just a weird Unix limitation. Whenever you use sudo, you have to type in your password. So, okay, I'm listening on port 80 here in my terminal. So I'm going to come over to my web browser. And then over here, I am going to go to this. And I'm going to see an error in here. But if I come back over to my terminal, you're going to see I've got a bunch of interesting stuff in here. So there is an error here. That's fine. The reason why it was an error is because we're sending stuff to the server running locally, and it's not like giving the client what it wants back. So the client's kind of a little confused right now. But like that's kind of the point, though, is this here is what was sent from the web browser to the server. In other words, this is an HTTP request. Any questions from anybody on that? Cool. Okay. So there's our HTTP request. This one's a little smaller, easier to put on the slide, but fundamentally the same kind of thing. So we're going to go through this bit by bit and break down what each part of this text means, and along the way talk about some important HTTP concepts. Okay, so the first thing, the very beginning of the request, is what's called a method. So think of the method in the sort of, like if you were to ask a question, if you think of the request as like a question, it's sort of like the verb. It's like the action you want to perform. By default, web browsers make GET requests. There are quite a few methods. The ones you will most likely run into in the near term are these: get, post, put, patch, and delete. Note they're all uppercase. That's just sort of how it works by convention. I said web browser makes GET requests by default. Yeah. Yeah, so you sort of just have to pick one of them. And as for which one you pick, like it's going to sort of depend on what sort of request you want to make, but we're going to get to that later. Okay, so that's method. The next thing, the slash here, is the path. So if we're going back to that sort of like English grammar analogy, the path is sort of like the subject of the sentence. So if you don't have a path when you make a request, like we did before when I went over here to localhost :80, the default path is just slash. But if I were to have gone to like localhost :80/student/1, for example, then my path would have been students/1. You can also put a trailing slash. It's sort of like a no-op. Like you can do it if you want, but you don't have to. There's also, we're going to get to talk about this probably either at the very end of the day or tomorrow. There's this thing called a query string too, a sort of another way you can include information in the path. I just sort of want to expose to you that it exists. And if you've looked at sort of your web browser URL bar before, you've probably seen these if you've dug into it at all. This is just sort of a place you can put extra metadata. We're going to talk about it later. I just want to expose you to it at least now. Okay, so path is sort of the subject. Method is like the verb. We also have our version. So remember yesterday how I talked about if you have a protocol? Or I guess rather, I talked about how protocols are important. And it's important to have both your client and server to be on the same page and speak the same language. And if they're not speaking the same language, you're going to run into a case where this client's going to send something to the server, and the server is just not going to be able to understand it. So HTTP and a lot of protocols, actually, this is a pretty common way to do it, solve this relatively elegantly by including in the protocol a version. So what's nice about this is, think of it like if you have, if like maybe you're multilingual and you can speak multiple languages. Imagine if someone asks you a question, they start the question to you with sort of the name of the language. So maybe I say like English, what's your favorite color? Or I say like Spanish, and then I insert whatever that phrase is in Spanish. Like the idea is by saying at the very beginning what language it is, you can, as the server, as kind of the computer processing it, you can read the first bit of it and then see, oh, okay, that's the type of data I'm going to get for the rest of the message. And then you can use that to sort of like pick which interpreter you want to use. Do you want to use the English interpreter, the Spanish interpreter, or the French interpreter? So in the case of HTTP, the only version we're going to really be talking about throughout the section I'm doing, and I think just in general, Yeah, I don't think there's really a reason you're going to talk about anything else. It's HTTP 1.1. Um, the reason why is there are newer things. In particular, HTTP 2 has sort of become a bigger deal lately, and there's also more unstable things called HTTP 3 and 4 too. But we're not going to talk about them because the underlying protocol that HTTP 2 uses is binary based and not text based. So it's going to be a bit harder for us to analyze and like investigate and look at. And because the goal here is understanding, we're going to focus on HTTP 1.1. All the concepts from HTTP 1.1 transfer to HTTP 2. HTTP 2 has some more extra concepts, but they're not like super critical. It's not like there's anything like wildly different that you're going to need like want to be cognizant of. So we're going to stick with HTTP 1.1. It's also kind of what I'm most familiar with, so I'm going to be able to help you the most with that. Yeah, so that's sort of the first line of an HTTP request. So method space path space version. Okay, after this, we have some more information. So we do that first line, and then you hit enter, you hit a new line. And then after you do that, you can include 0 to n, 0 to as many as you want, of what are called headers. So think of headers kind of like a JavaScript object. It's like a key value sort of situation. So you've got a key, in this case, connection, and the value, in this case, keep dash alive. And the way that you tend to structure these is the header name is in what's called train case, or if you're not familiar with that term, it's sort of like a bunch of words where every initial letter of each word is uppercase with dashes in between. So like this, for example, and you'll see like user agent over there, accept encoding, accept languages are all sort of in that format. These generally are used in requests to include metadata. And we have a whole day. We're going to talk about headers probably the week after we get back from the summer break. I think maybe the first day after we get back, we're going to do that. So like today it's more just about that headers are a thing. They're for including extra metadata in a request. Like a great example is the DNT header here. It's one you can include that will tell that indicates to the server that the client browser doesn't want to be tracked by the server. This user agent header is one you can include as the client that sort of gives the server information about the browser making the request. So things like that, more like informational in nature. In general, this isn't always the case, but in general, headers don't like directly affect like the or don't directly pertain to like the operation being performed. They're sort of like extra metadata. So the way that these headers are formatted is you do header name in train case, colon space, header value. So you can see here like user agent, colon space, Mozilla 5.0 and all the extra stuff. And then once you're done with the header, you do a new line. So name, colon space, value, new line. Name, colon space, value, new line. You can do as many of them as you want in a row. If we go back over to the request I made or here, you can see there's actually quite a few of them. So you've got like host connection, cache control, all these. I guess these aren't fully in train case, whatever. Accept language. This cookie one is like really long. So once you're done with your headers, so like if you think about it, if you did like header name colon value enter, header name colon value enter, you kept doing that over and over and over, there's no real way to tell the server like you're done by doing that. Like if you do a new line and you start typing something else, the server is just going to think that's another header name. Like you need some sort of way to tell the server like I'm done with the headers, I want to move on to the next thing. And the way you do that in HTTP 1.1 is you put 2 new lines in a row. So name, value, enter, or key, value, enter, key, value, enter, and then one more enter. So it's enter, enter. So that's how you complete that section. Also, I realize I'm throwing a bunch of information here. We're going to actually go through this. We're going to do some demos. Just want to sort of get all this stuff out there to start with. Okay. So lastly, we have what's called the request body. So think of this sort of like everything else in the sentence other than the verb and the subject. So any like adjectives you want to describe things, any like direct objects or other concepts you want to include in your grammar. This is sort of where the majority of like the important stuff that you want to include in your request goes. Importantly, bodies tend to not be included in GET requests. So if we look here at this request I made, you see there's at the very end of this cookie header, we have enter and then enter, and there's sort of nothing after that. So there's no body being included in this request. We're going to do a request in a moment that has a body as an example, but like literally the body is just like whatever arbitrary text you want. And then that's sort of the end of the request. Once you include those 5 bits, the method, the path, the version, headers, and the body, you sent everything to the server it needs in order to process your HTTP request, and you've sent it in valid HTTP format. So, okay, here we go. Yeah, here's an example post request. So method, path, version, enter, header name, header value, enter, header name, header value, and then enter, enter, and then the quick brown fox jumps over the lazy dog. That's sort of our, that's sort of our like body. Okay. Any questions on any of that? Okay.
One question. The content length is the number of characters in the
Yeah,
body?
good question. So yes, it's a header that's included. We're going to talk about this probably in about like 15 minutes. But the content length is a header that you tend to include in your headers that tells the server how many characters will be in your body. So what is it like? Why this is important is if you imagine you're the computer and you're just getting this response character by character, one by one, once you get new line, you're able to process all your headers and say, oh, okay, I need to read 44 more characters and then I'm done. So you read 44 more characters, and once you've read those 44 more characters, you get number 44, then you're like, oh, okay, my request is complete. I can start thinking about it and getting ready to send back a response. So that's why that's how it tends to work. If kind of like the 0, you typically don't include it. Like if we go over back to the GET request here, there isn't a content length anywhere in here. So it's because it's a GET. There's no body in the request, so there doesn't need to be a content length. But yeah, you got the right idea. Good question. Okay. Now we're going to talk about the other half, responses. So just like requests, I have a nice little demo to do here. So what I'm going to do is I'm going to do the same demo I did before, where I make a request from the server, from the client, my web browser, to the server. Instead, though, after I go through that, instead of just like letting the terminal with netcat just hang there, I'm going to take this text over here, which we're going to talk about what this means in a second, and I'm just going to paste this in the terminal, and we're going to sort of see what happens. This is, if you can guess, this is an example of an HTTP response, but we're going to break it down in a second. I just want you to treat it as sort of like a black box right now. So, oops. So I'm going to go over to here, start this again. I'm going to take this and copy in my clipboard. Okay, so I've got that running. So I'm going to refresh this, and I'm going to paste this in. So I refresh it, and I just hit Command V in my terminal. And a few interesting things happened here. First of all, netcat quit. So you see how I have my prompt back here? So the way that a lot of web servers are configured by default is when you send a response, the TCP socket underlying the request just terminates. So you get one TCP socket sort of per request response interaction. There are ways to sort of configure it to allow you to send multiple on one TCP socket, but that's a bit of above and beyond and not that important at the moment. But it terminated. So that's the first thing. The second thing is, I want you to notice that it says now, instead of showing an error in my web browser, it says hello world on my web browser. What slide number did I copy from? This is slide number 99. Right here. So what I did here is that diagram we had before with like the C and the S, that's sort of like two computer little diagram where we're sending the request, getting back the response. I just went through a full cycle of that. So the web browser sent the request. In my terminal, I pasted the response. It sent it back to the web browser. We see the thing. So if you think about this a bit conceptually, imagine that instead of sending back the text string hello world, I sent back some HTML or something like a bit more interesting. That may be, if you think about that, like now you're starting to just kind of see like that's how a web browser works. So I'm getting a bit ahead of myself, but that's sort of where we're going. Okay. Oops. So we just went through that exercise. Here's an example of a response. It isn't the exact response I pasted in there. The one I pasted was a little bit smaller and sort of minimum of what needed to work there. This is a response that probably would be a bit more typical of what you typically get back. You'll see some things in here that look probably relatively similar when you compare them to a request. So some things that look kind of header-like, a thing that looks kind of like a body, something that looks kind of like a version, but there's some new things in here too. So here's all the bits of a response. We have the start with our response, the version, the protocol version. So think of this sort of like when you reply back to the question, you start your reply by effectively saying, I'm speaking in English, or I'm speaking in Spanish. So by doing this, it actually means that technically with the way that HTTP works, it is possible for you to respond to a request with a different protocol version than the request was sent in. In practice, it doesn't really ever go down that way, but it's definitely possible. And which is kind of cool that it like builds in that ability. So that's sort of the version that of the protocol that's used in the response. Next is status code and status message. I'm going to hold off on these. We're going to talk about these separately in a second, but these are new. These weren't included. Anything similar to this wasn't included in the request. We have what are called response headers. So importantly, headers were included on our request. You can also send headers in a response. They serve a similar purpose as the request. So if you want to send headers in your response, they're just purely like metadata informational. So like an example, content length, similarly to a request, you include that header to say how long your response body is. You could include a header that says like the current timestamp on the server. Maybe you want to know that. Or like the type of data that's being sent back in the response. We have a whole day we're going to talk about headers, so I'm not going to get too far into like what all these mean, but they're purely for metadata informational types of purposes. And then lastly, we've got a response body. Exact same idea as the request body. That is where the primary data tends to be for your response. Note that, like I talked about before, how a GET request doesn't typically have a request body. Everything always has a response body. So no matter what method your incoming request came in, I guess I should say always, like 99% of the time, you'll have a response body. If you don't have a response body, it typically would just be like empty. So it'll be kind of like it is with the how it was with the GET here before. But like you're basically always going to have a response body. So the structure of this is the same kind of thing as the request. So sort of a series of new line separated lines. And you have the same sort of like header name, colon, header value, enter, header name, header value, enter, and then the double new line, and then the response body. Okay. We didn't talk about one thing though, in that the status code and status message. These are brand new. Something we haven't talked about when it comes to the request. So these are how the server in the response indicates to the client how successful it was in responding to the request. So there are a number of different standardized codes that can get sent back. Some of these, if you sort of have spent time on the internet, might sound familiar. Things like 404 not found. But there is a whole list of them. And here, right here on the slide is sort of a list of probably the most like handful of most common ones you'll run into. In particular, though, 200 OK is probably the one you're going to see the most. If like that's kind of like the generic, like everything went great response. You'll see here we got a 200 OK. There's a bit of a trick you should know with these things. So you'll notice that all of these in this list start with 2, 4, or 5. The 3-digit numbers start with 2, 4, or 5. So the way that these break down, all the codes that start with a 2 means that things went okay. So like 200 okay, and there's the whole bunch of other 200 codes, like 201 created, 202 accepted. These all mean different things that all generally are like different flavors of the request went well. You have a valid response that's being returned. A code that starts with a 4 means there was an error, and that error had to do with the client sending data that was bad in the request. So that might be you tried to make a request to a path that didn't exist. That's a 404. It might be you didn't include a body or your body was malformed. That's usually some sort of like a 400 bad request. It could be you're trying to make a request to something that you don't have access to. It could be like a 401 unauthorized. And then anything that starts with a 5 means there was an error, but it was not the client's fault. It was the server's fault. So this could be like the server's malfunctioning, just the generic 500. I guess I should also say that like 200, 400, and 500, sort of the like 0 ending versions of those codes, those are sort of the generic versions of each of these categories. So 200 is generic success, 400 is like generic client problem, 500 is like generic server problem. But there's other 500s, like you might run into like 504 gateway timeout if like the server is misconfigured, or oh gosh, there's a bunch of others too. But you'll see that like I'm rattling these off. With enough time, you'll just like see these things so much where you'll just sort of memorize them. Like it'll happen. But like in general, until you get to that point where you memorize them, this sort of breakdown, the 2, 4, 5, 2 being good, 4 being client problem, 5 being server problem, is like a good place to sort of start and help you like intuit what you're seeing. So I've included here this link. This is just to Wikipedia, a list of every HTTP status code. So if you want, you can check this out. There are a lot of them. There are like other like 1s and 3s. We didn't talk about those. Those are sort of a little different. We will talk about 3s a little bit later in the section, but so you can sort of read about what all these mean and how they work. But we're going to kind of skip by that now. Okay. So we have talked about requests and responses. We're going to actually start to make some requests and responses. But before I do that, I just want to put it out there. Anybody have any questions about anything I just covered?
Yeah, and what event will you have a forbidden error code or
Ooh,
status
yeah.
code?
Good question. So generally there's this idea of what are called permissions, often in web things. Permissions are like, imagine you have a bunch of user accounts, and maybe you have 2 different types of users. You have like a user that's like a read-only user, and you have a user that's like a read-write user. And let's say you are currently logged in as like a read-only user, and you attempt to perform a request, it's like a write, some sort of like creation or like modification, but you don't have access to do that. A 403 forbidden means you're authorized properly, like you're logged in, you're a valid user, but the action you're trying to perform, that particular like operation, you're not allowed to do it because you don't have permission to do it. Does that make sense? Cool. Anybody else have any other questions? Okay. So we are going to make some requests together. This is sort of where we get to a bit more of an interactive part of the lesson today. I have a server that I put together on careersincode.xyz, just like yesterday. Importantly, though, yesterday we were talking on port 4000. Today, we're going to be talking on port 80. So we're going to be making HTTP requests. That's why it's on port 80. So I just want to call out also that if you were to go to careersincode.xyz in a web browser, you would actually see a little web page. So what I'm doing here is this, like we saw before, like the web browser is making a request, the server is returning back a response. So this is actually like a little example as to maybe like what I was talking about before, where this is sort of like a super basic web page. And if you wanted to give it a shot, maybe later on, you could try to make a request to sort of the slash path and sort of see what you get back. Okay. So we're gonna do this first one together. You can either follow along with me or you can wait until I'm done. You can do it on your own. But I just want to I want to make sure everyone can do this before we move on, because it's sort of this is a relatively straightforward request and sort of should help give everyone some practice. Okay. It's a little smaller. There we go. Okay. So I have here I'm asking here to make a request, a GET request to /fruit with no headers. So just like yesterday, we're going to use netcat to make this request for today. So I'm going to type nc careersincode.xyz 80. So just as a quick review from yesterday, this is going to open up a TCP socket to careersincode.xyz, which behind the scenes points to an IP address, but that's not that important, on port 80. So I'm going to hit enter, and it's going to open it up. Okay, so now netcat's running. I'm going to give it my request. So here's a little example here from the slide to sort of break down what we got to do. So the way that the first line goes is method, path, version. So method, get, path, fruit, /fruit, space, version, HTTP 1.1. I do want to call out that really you got to make sure you get this correct character by character. Like, get can't be lowercase. You can't have like extra spaces. You can't have like, extra slashes, extra characters. You need to spell things correctly. So after I do that, I'm going to hit enter. There's no headers, so I don't have to type anything here. So I'm just going to do another new line. So I didn't add any headers. I hit another new line. And once I did that, my request was complete. So once that happened, you can see, so this is my request. I got back a response. So HTTP 1.1, 200 OK. So because it's a 200, it starts with a 2. That means things went well. We got back a bunch of headers all here. And then I got back this text string, apples, oranges, bananas. So I'd love if everyone could give this a shot on your own if you haven't already. once you've done it, if you're able to have success, you can give me a thumbs up or a reaction or post in chat, just so I know how folks are doing. But give this a shot. Let me know how it goes. I'll give you a few minutes.
So I'm getting bad requests.
You want to share your screen and let's take a look?
Sure thing.
Okay. Ah, yeah. So I wanted to take a look at the slides. If you have them open, if not, I can share them again. In particular, take a look at the casing of the method.
Yes, it should be capitalized. I'll try again.
Yep, no problem. Yeah, again, it's really important you get the characters by character stuff correct. And I'll say, for what it's worth, this is going to be really annoying today. You all are probably going to get really frustrated with me and really annoyed that you got to be like, oh, I screwed up a character. I got to type this whole thing again. I guess I think it's probably gonna be worth saying that, like a math class, this is sort of the example of us doing it longhand to sort of show you how it all works and to give you a mental model of what's going on. Depending on how it goes today, either at the end of today if we have time or tomorrow, I'm gonna show you some tools to let you make requests in a more abstract way, sort of like pulling out the calculator. And once you do that, you're never gonna do this ever again. So like this is more like the educational exercise to give you the mental model. Like, know that the typos that you're dealing with here, these are not something that you actually run into on a day-to-day basis because the tool does it all for you. Sweet. Anybody else have any difficulty and want some help? Or I saw a bunch of thumbs up before, so I'm guessing things went pretty well. Okay. Let me share my screen again here. So I did this one, we did this one together. So this is the response we got back: apples, oranges, bananas. Here's the next one. So this one's a little bit trickier. We've got a body we're including in this request. So this request, when we make this request, it's going to give us back the frequency of all the words in the input or in the body that's sent in. So a great example here, like the quick brown fox jumped over the lazy dog. Like you have the in there twice, so it should see like the is 2, and all the other words should be 1. So it's going to sort of count up all the words and tell you the distribution. Since the other ones seem to go relatively well, I'm going to let you all give this one a try on your own. Give you a few minutes. If we need to, we'll go through it afterwards. So if you're having difficulty, you can still see. But Okay, how's it going, folks? If you've been able to make the request successfully, can you give me a thumbs up? Okay, I see like 2 or 3 thumbs up. Do you all want more time or do you want to go through it? What do you think would be most helpful? Okay, I think I'm going to give a little more time.
I got a question. Do I just
Yeah.
put it all in one line?
Yep, all on one line.
Oh, do I include the HTTP, the language in the 1.1?
Say that again.
HTTP. Do I say like, do I include HTTP dash 1.1?
So keep in mind that needs to go on the first line. That wouldn't go on the line as your body.
Oh, okay. I think I know what I did wrong. Thank you.
So I will say, if you did want to include a new line in your body, you could, but that would count as a character. So when we talked about it before, that content length header is being included in the request headers. If you wanted to put like a new line in the middle, you'd have to add a one to the 44. You have to make like 45. And then if you put the new line in there, like that sort of counts as one of your characters, if that makes sense. Okay, I'm tempted to go through it. If anybody wants one more minute or so, speak up now. Okay. So pull my terminal back up here. So I'm going to make a request to Queries and Code on port 8000, open up a TCP socket. So my method is post. My path is text processing frequencies. My version is going to be HTTP 1.1. I'm going to do an enter. Then my header name is going to be content length colon space. So key colon space. My value is 44. I'm going to hit enter. I'm going to hit enter one more time. And I'm going to type the quick brown fox jumped over the lazy dog and hit enter. After I do that, I get back this. One thing I should mention, just to, I guess, be fully transparent, the way that Netcat works, for it to actually send data out to the server, you have to hit enter. So if you just type your body and then don't hit enter afterwards, it's not actually going to get sent to the server. That's just sort of like a Netcat intricacy. That's kind of why that is. But okay, back in our response, we got back version HTTP 1.1, 200 OK. Again, 200 OK, it starts with the 2. Everything's going great. We've got back a bunch of headers, and then we have a body. So each word is once, and then the is twice, which is, I think, what we'd expect. The and every other word's unique. Okay. Anybody have any questions on that one? Okay. Let's do this next one. Just like before, if you're able to get it, give me a thumbs up and feel free to speak up if you need any help. if you've been able to get it, try making the request again, only this time make the header value something other than that word super secret. And you should be able to see a case where the request fails. So that's maybe a unique thing we haven't shown yet. So give that a shot if you want a stretch goal. Okay. Anybody want any more time, or do you want me to go through it? Okay, I'll take silence as let's go through it. So again, making request occurs in code XYZ on port 80. So my method's get, my path is /lockbox, and then my version is HTTP 1.1. My header is authorization, super secret, and then under my body, so I'm just going to hit enter. And now we get back this response. So HTTP 1.1, note this time we didn't get a 200 OK, we got a 201 created, but it still starts with a 2, so that means generally went well. We got back a bunch of headers, and then you have unlocked the box. Let's try this again this time. Let's include a different header value. It's not super secret. I mentioned that as a stretch goal. So here's what that would look like. So get lockbox, HTTP 1.1, and then authorization, and then maybe like bad. So in this case, HTTP 1.1, this time we got a 401 unauthorized. So a 4 means something the client sent wasn't right. We got back a bunch of headers and then our response. Cool. So I have a few more of these. It looks like folks are doing pretty well with this. They're all kind of just variations on what we've done here. So I guess if you could, let's see, it would be the best way to do this. I guess I'll stick with the Zoom reactions. If you think it would be helpful for you to do one or two more of these, give me a thumbs up. If you want to if you feel comfortable with it, you want to move on, give me a thumbs down. In hindsight, I probably should have flipped those. So I guess the thumbs down means you're good. Nice and confusing.
Actually, can I share my screen with you? I don't know what I'm
Yeah.
going wrong. At first, I was missing the colon, but now I'm like, where's my error?
Cool. Okay. Yeah. Share your screen. Let's take a look.
This is it. This is what I did first. And then it gave me nothing. So I started all over. Did I spell secret wrong?
I think you spelled lockbox wrong.
Oh, lockbox. That's true. All right, let's do it again.
I'm seeing, sounds like we're gonna do a few more of these. Sounds like you all want the practice, which cool. Hit enter one more time.
Oh,
There we
forgot
go.
about that. Oh, thank you.
Yep.
I forgot about that second enter. I thought it was like, it's not doing anything.
Yeah, you gotta hit that second enter to tell it the headers are done. Okay. Anybody else have any questions? Now I'm seeing it's kind of got a pretty good split. I think we'll do at least one more. And then we'll probably take our break. And we're doing so this lesson, when I give it, either tends to go relatively well or like really kind of crashes and burns depending on the group. It seems to be going relatively well, which is good. So I think what we're going to do is when we get back from our break, we're going to start what we're going to cover tomorrow. And by doing it that way, it means we're going to have time before the end of the week to leave you off on a cliffhanger to think about over the long break, which will be good. I should say, like, the way this section is structured, it starts off relatively easy. Like, what we covered yesterday, what we covered today, like relatively straightforward conceptual stuff. It's gonna start to ramp up tomorrow a little bit, and especially like at the end of tomorrow, we're gonna be talking about getting back over into some JavaScript stuff, which I know you all probably are super comfortable and love JavaScript right now. So yeah, we're gonna get back to that, but we got to sort of work up to it a little bit and give you some of the conceptual background. Also, on Monday, Max, I believe, talked about some things called promises with you. Where those are going to come up as well. We're gonna hit it a few times though, so don't worry. We have there's a plan here, but okay. Let me get back over to the presentation, but. Okay, here's another one with a body in it. Give this a shot if you want the practice. We'll probably do. I think what we'll do is we'll do this one, and then we'll probably take our break, and then I'll leave these remaining two in the presentation. If you want to do them on your own, feel free. And if you have any questions, like send them to me. I can take a look when we get back from break or after or whatever. But I'll give you all a chance to give this one a shot if you want the practice. Sorry, folks, having some technical difficulties here. Sorry. Okay. Go through this one. So, making a post request to text processing most common word. HTTP 1.1, so method, path, version, headers, content length, 44, enter, another enter, so to tell it I'm done with that header section, and then the quick brown fox jumped over the lazy dog. Hit enter, and the most common word is the. Got back a 200 okay, so it means things went well. Got back a bunch of headers. So that's roughly how this one should have gone. Any questions? Any extra information? Any or any clarification anyone would like with this one? Okay. I think then we're probably going to take our break. We should do attendance though. Oh gosh, I got to pick a word. What word do I pick? Maybe like quick. Quick. Oh, there were a bunch of suggestions. Whatever. I picked already. So that's our word for the day. So fill out your attendance with that. And then I think we'll Christelle, you asked, as it stands, does the code allow for any body input for this path or no? You're talking about for the most common word path?
Yes.
Yeah, so it should. If you pass the body to that request, that's how it's going to like know what to process. Cool. Okay. I think let's get back at like 7-ish. Does that work for folks? Cool. So we'll get back at 7, and then I think we'll jump into section 3, which is HTTP tools and libraries. We'll start that. We probably won't finish it. We'll probably get like through the first half of it. And then that'll be it for the day. So cool. Okay. See you all at 7. Share my screen again here. Okay. So we covered before the break HTTP, the protocol, how it works, all the bits and pieces, what a request is, what a response is, all the different pieces of each. And we made some requests and responses to a server I set up with Netcat. Now we're going to talk about some other tools you could use to make HTTP requests. Now, the way I've structured this is sort of like the next day, but we're going to start it now. We're going to go through maybe the first, maybe like third of what's in here. And by doing it this way, I mean, I mentioned this before, but I think it sets us up nicely so that tomorrow we'll be able to leave things off at a bit of a cliffhanger that you can think of over your break. Think about, as it's I think going to be a bit of a challenge, let's say. So I said earlier that you don't ever actually make HTTP requests with Netcat. It's not actually something that people really do professionally. I made the analogy before. It's sort of like in math class, how you have to learn long division to understand kind of how it works and the process. And it's important to know how things work behind the scenes. But like, if you're actually doing lots of math, 95% of the time, you're just going to pull out a calculator, put in your numbers, hit enter, and get the result. It's a lot faster, it's a lot more efficient, and it's what people actually do. So we're going to talk about some tools that people actually use to make HTTP requests. We already talked about web browsers that they can make requests, but I guess in particular, I'm talking about like, you're an engineer, you want to make a request to test something. How might you go about doing that? And there are 3 tools we're going to talk about to do this: Postman, curl, and fetch. This is sort of going to take us from now until the end of the week, so end of tomorrow, to sort of get through all of these. Postman is a tool that allows you to make HTTP requests with like a graphical program. So think of like a program you download on your computer, and you can sort of click on it and click through and tell it all the information about a request, click go, and it'll make a request for you. Curl is a command you can use in the terminal that'll make requests. And we're going to talk about why that's important tomorrow, but it can be helpful in certain contexts to be able to make a request in the terminal. And then lastly, what we're going to talk about tomorrow, way sort of near the end, is fetch, which is how you make HTTP requests from JavaScript. And that's going to be fun, and I think a bit of a challenge for you all, but that's sort of where things start to get really cool and powerful. So we're going to cover Postman today. We're going to cover curl tomorrow, and we're going to cover fetch tomorrow. So this should actually be this. Well, okay, my slides are all messed up now. We're definitely not going to cover this in this class. Okay, so Postman, as I mentioned before, is a graphical interface for interactively making HTTP requests. I would like you all to download Postman. So there's a link in the slide you can click to go to their website, and you can download it. Or you can just type it in, www.getpostman.com. I have this video down here, which you may or may not be able to open on your end, but I'll play it for you here. It sort of walks you through what you need to do to install it. So I would just do this myself, but I already have it like installed. Like I've installed it a while ago, so I don't need to go through this. So if you go to Postman, then you're going to want to click download the desktop app and then Mac, the Apple. And you all have Mac Apple chip devices. You're going to want to click Mac Apple chip, and it's going to download a zip file. I'll go through this one more time if folks want me to repeat it. And then once it's downloaded the zip file, you can click on it, open it up, and it'll give you this postman.app, which you want to drag into your applications folder. And then at that point, you can double click it to open it. So I'll give folks a second to go through that. If you have any questions, let me know, or I can play the video again and we can talk through it. But in order for you to continue with the rest of what we're going to talk about today, you're going to need to have Postman installed on your computer. Once you get Postman installed, you should see something like this. Actually, wait, I guess I should finish this up. There's a couple steps you got to go through once you open it. I forgot. Okay, yeah, so something like this to start with. So create an account or sign in doesn't really matter. If you want to make yourself an account, you're more than welcome to. There's nothing we're going to do today or for the rest of this class that requires it. What an account will let you do is sort of like save in like requests you're working on to the cloud. And Postman has a bunch of like cloud related features that you can tap into if you want. But we don't need that. So either feel free to make an account, or if you don't want to, there's a little link down here, skip and go to the app. You can just click on that and skip it. And then once you're in, you should see something that looks kind of like that. This is where I'll jump over to my real Postman over here. So I'm seeing some thumbs up in the chat. Anybody having difficulty or running into problems?
Yeah, I made an account, but my screen doesn't look like yours after I made it.
Can you share your screen? Let's take a look. If you go to the upper left and click home, what does that do? Oh, is this home? Oh, maybe click on my workspace. Yeah, there we go. And also, if you want to collapse that sidebar and to give yourself some more room, you can click on that little collections button on the column on the left, and that should collapse it so you can sort of see more stuff, which might be make it a little bit easier to follow along. Cool. I'm tempted to keep moving forward, but I don't want to do that if folks are still waiting for things to install. So if you're, I'll probably maybe give everyone like 15 more seconds. If you're still working on it, let me know though. No problem, I can wait. Okay. So what you're going to see once you get Postman loaded, you're going to see something that looks kind of like this. And in general with Postman, there's sort of like two bits. So it's the top bit and the bottom bit. The top bit is where you put in all your information about the request you want to make. So you can see here some things that probably look kind of familiar. Oh, like get for their method. You see a box with some like a domain name in there. You see some headers. So there's some things we've talked about earlier today. And then the bottom part is where your response is going to go. So after you type everything you want in the top, you click send, the blue button, and then you get in the bottom all the sort of information that we got back in Netcat. So here's kind of, we got our method, we got our request headers, URL, we're going to talk about that in a second, request body, and then in the response, we've got our status code and then our body, and also some headers and other bits of information as well. So there's a term that I haven't actually used yet that we're encountering now, URL, that I want to talk a little bit about. So if you've used the internet a fair amount, you've probably come across this term, or also URI. It stands for Universal Resource Locator. And this is sort of like the thing that typically goes in the web browser bar up there. A URL is sort of a means of combining a bunch of different things that you want to include that all sort of relate to like kind of where the request is going. So a URL allows you to combine what's called the protocol, the domain name, the path, and any query parameters, all in sort of one big string. And what'll happen is when you make a request, that'll get broken down into all the individual bits, and those will sort of get substituted into their proper locations. So the protocol, the bit at the beginning that goes like HTTP:// that says what protocol you're speaking on, which defines the default port. So in this case, it means that requests are going to be made on port 80 by default. Example.com is our domain name, so that's sort of the bit that would go at the beginning of netcat. /students/1's our path, and then the detailed true is a query parameter. So this is kind of how that breaks down. So the protocol sort of does the port, and then the host name and the path and query parameters. Note that the query parameters, which we're going to touch on a little bit more later, those sort of go in with the path. So it's sort of like everything afterwards all go here. So a few tricks about Postman that are worth knowing that I think like everyone they first use Postman, they run into like these weird gotchas. Like Postman isn't the most intuitive application. You have to sort of like learn how to use it. So the first thing I want to cover is if I'm making a request. So let's say I make a GET request and I'm making a request to like careersincode.xyz or something like that. And I want to include a custom header in the request. What is going to seem like the thing you want to do is you're going to see, oh, here. And you're going to put like, start typing stuff in here. But that's not headers. This is a different thing. These are query parameters. Headers are this tab right here. So it's this third tab. You actually have to go to that before you can enter the headers you want to include in your request. So if you want to enter headers, make sure you put them in the headers tab and not the params tab. They look very similar, so it's easy to make that mistake. Also, if you want to include a body in your request, so let's say this was a post request, you go to the body tab to do that. But when you do that, you almost always want to select raw. So if you have none, that's sort of saying like your request doesn't have a body. So it's like maybe it's a GET request or it's a post request without a body or something. If you go to raw, now you actually have like a text box. You can type in what you want your body to be. So if you don't do that, then you won't have like that. You won't have a way to do it. And there's other options here too that sort of like try to format it in different ways. For everything we're going to do in this class, the only things we're going to use in body are just none, so no body, or raw, which is just arbitrary text. Okay, those are the two gotchas that everyone kind of runs into with Postman. Let's do a demo of making a request to that fruit endpoint we made a request to before. So it was /fruit a get on careersincode.xyz on port 80. So to do this, I'm going to make a GET request. And then my URL is sort of, I'm going to combine all those bits together from both the request, the original like TCP request that I was doing with netcat, and also the path that I'm making the request to as part of the HTTP request. So HTTP:// that sort of implies port 80. Careersincode.xyz is my domain name. And then /fruit. So I don't need to add any custom headers. I don't need to add any custom body. So once I fill this out, I'm going to click send. And I get back the same thing I got before. So you can see apples, oranges, bananas. You can also see I got back a 200. So it'll actually, what's cool is Postman will tell you what all these mean. It'll also color code them. So 200 okay, it's green, which means things went well. And it'll tell you what that means if you don't know what a 200 means. So I would like if everyone who's gotten Postman downloaded and everything seems to be working to give this a shot. try to make this request with Postman. And if you're able to, if things work well, give me a thumbs up, either reaction in Slack or in the chat, just so I know. And this will be sort of a good first shot at using Postman. Hopefully, it'll also be way easier than using Netcat.
Did you put in any headers?
Nope, no headers, no custom headers. Okay, I saw a bunch of thumbs up from folks. Anybody have any questions or want me to go through this or troubleshoot if it's not working for you? Okay, we will keep moving then. So, all we're going to do for the rest of the class is we've got a couple request examples. So I've got these two here. I would like you to try to make these requests on your own. So try to make number one and then number two. These ones are a little more difficult than the one we just did. You're going to have to enter headers or body stuff for some of them. Actually, I guess just body. Yeah, I guess I don't have one with custom headers. Interesting. But yeah, give these a shot. Let me know how it goes. If you have any questions, feel free to speak up. Okay. Anybody need any more time? Okay. Let's do this one. So get cruising code.xyz. Actually, I'll do this start from scratch. So get cruising code careers plural / apples. So no headers, no body. We'll send that one off. We get apples. We get a 200, so everything's the request succeeded. So that's the first one. Second one, you have method of post. Post names, same thing. So careers in code.xyz. And this one /echo. And we need to give a body. So I'm going to go to body. I'm going to select raw. And then for the body, I'm going to type hello. And when I click send, we get hello. So it's going to send back whatever I included in the body, in the response body. Got back a 200, so everything worked that well. And those were the two. So that's all for today, I think. Tomorrow, we're going to talk about curl, and we're going to start talking about fetch. So these are two other ways you can make requests without using Netcat. And then that should be fun, give you something to think about. And then you have the week off for your break, so that should be good. Any final questions before we finish up for the day? Great. Okay, well,
I have a question.
yeah,
Um,
go for it.
for the midterm, what we're gonna cover tomorrow, is it gonna be enough to like do it over the break?
By midterm, you mean the New York Times thing?
Yeah.
Okay. I would say you might be able to start it, but you're not going to be able to complete it.
All right. Thank you.
Yep. Just for I don't know how much Max has shared. It sounds like already a bit, but there's at the very end of this whole section that I'm teaching, we've got an assignment called the New York Times assignment. We're going to talk about it tomorrow at the beginning of class, but it's sort of like Max kind of considers it to be like the midterm for the class. It's a good sort of like summary of all the skills you've learned up to date, and you also get a nice little project that sort of is like a like thing that you can show that actually like does something, which is kind of cool. Yeah, the attendance code was quick, the word quick. Okay, I think that's all then. Unless there's anything else, have a good evening, folks, and see you tomorrow. Bye.